Welcome to another episode of Complete Developer Podcast, the podcast by coders for coders about all aspects of creating your best life as a developer.
I'm Will, the accomplished developer and aspiring software architect.
And I'm Beej, the journeyman developer sharing my journey in development. If you have an HTTP-based API, you're most likely using the principles of REST to organize your system. While building such a system, it's helpful to organize your code in a way that is not only clean and eloquent, but that is thoroughly predictable to both new developers and anyone else working with your system. In this episode, we'll discuss some anti-patterns and common mistakes that you might see when using REST, along with why these are mistakes. But before we get started, Will, what have you been fighting this week?
Well, so about a week ago, I guess it was, I looked at the way I was storing all of my documents, my MP3s. You know, I have like courses that I've bought and I've downloaded and I've got them. And I was looking at it and I realized that the way that that stuff was laid out was based around having much smaller hard drives than I do now. And so it's like broken into sections that synchronized in, separately. And I had like 25 of them. But now I've got the NAS. And when I moved over to the NAS, I just moved all that stuff and did the thing and I'm like back up and running real quick. And so last week I was like, I ought to fix that because this is organized in the way that was useful to me in 2008. Okay, cool. So I got Sync Thing and I've, been doing all that stuff. So I made my new directories. I set up all the backup stuff to, watch these directories and move the stuff around. It took about 20 hours to get everything synchronized inside the house. And my network connection was pretty heavily saturated for about 4 days. It was awesome. You start it and you actually get the move going. So I think it was like 3:30 on Friday is when I actually started the robocopy scripts to move all the stuff around. I scripted out what I was going to do and told it to do it. And yeah, my network connection was well saturated up until I think the middle of the day yesterday. It's been real annoying. I think it probably isn't hurting other things, but it's like hurting the machines that I use. And now the backup set is running. And so it's been miserable, dude. Like I've been thinking about like downloading an MP3 of like one of those old school modems and just like setting that as the opening sound when I open a new tab in Chrome, because just to get the feel for my connection speed. Anyway, it's caught back up. So I'm back in the 2020s now as far as internet speed. So I got that going for me. How about you?
Well, actually, just before we got started, I got a text from our tech lead at church. They had Comcast come out because we had the business plan and we're not getting what we should. There's some issue with the line coming in, but now we're up to like gigabit speed at the church for streaming and stuff. So that's cool. That's what that reminded me of. Oh man, interruptions are killing me at work. If it's not QA asking how to test something, it's some level of management asking for an update. I finally had to send an update that said I spent all day sending updates.
Yep.
Which was not facetious.
Yeah, it's funny how often you and I get into that situation where we say something and people are like, oh, he's just being funny. It's like, no, really, I was 100% serious. Like I was telling you, I had that earlier today where somebody said, Will, pull master. And I'm like, was Will a noun or a verb?
Yeah.
In that sentence you just said, because that kind of matters to me.
Yeah, that makes sense.
Yeah.
No, I said I had like an hour-long conversation with one of the directors about updates. And it was said, I'm sure it wasn't an hour long. And I took screenshots of the Slack conversation and sent it and said, yep, it was an hour. Started at 9:30, ended at 10:36.
Yep.
Yeah, I was just like, yeah, that's what's going on. Now, speaking of going on, as things are opening back up, one of my friends from church bought himself a motorcycle. So we've been riding. Honestly, it's fun to ride out somewhere with someone and have a beer. I've missed doing that. Like during the quarantine, Amanda and I were trying to, support local breweries. So we would ride out to some of the breweries and buy beer and then ride home and drink it. because you couldn't drink it there. But being able to like ride out and sit and have a beer was nice. And it's really cool because he's an engineer who does a little bit of coding as part of his job. So Saturday, I was telling him about some of the stuff that I've gotten to do lately and ended up giving him a lesson on recursive functions and how they work.
Did you put another lesson in it? Yo, dog. I heard you like recursion.
Dude, though, seriously, you should have seen his eyes light up when I explained. I said, yeah, I got to write this really cool recursive function to deal with some file system stuff. And he's like, what's that? And I was explaining, a method that calls itself and how that works. And he was just like, that's possible. That's so cool. Because everything he's done has just been to automate and make his job easier. It's not been like because of programming. And so I'm going to make him a programmer yet. He really thinks it's cool. So
nice.
Yeah. Now, Mother's Day was 2 weeks ago, 2 Sundays ago. Is that right? Yeah.
It's all blurred together at this point.
I know. But my aunt was very sick. She actually passed away on Mother's Day. So my mom had to cancel our plans and spent the whole weekend with her. I actually didn't see mom until this past week. So we had Mother's Day this past Sunday with her. Amanda and I went over there and had barbecue and wine because why not?
Seems fair.
Yeah, it was fun. We had a good time. So with that, let's go ahead and get on into book club. This week, we are talking about the 6th quality of a team player, dependable. And a quote from the chapter, teams go to players. Maxwell starts off telling about Christopher Reeves, the man who played Superman in the original movies, and how he was thrown from a horse and became a quadriplegic. He went from being in peak physical condition to needing a team of people just to function daily. Reeves had to depend on these people for his very life. Maxwell then talks about what he sees as the essence of dependability. First, he says that a dependable team member will have pure motives, not putting their agenda before the team. Next is responsibility. Team members desire to do the things they are capable of doing. And third is good judgment, which must be combined with responsibility to make a dependable teammate. And finally, he states that dependable teammates are consistent. Closing out the chapter, he gives 3 ways to improve your own dependability. Look at your motives, find out what your word is worth, and get someone to be an accountability partner. Or if you're a South Park fan, an accountability buddy.
I'd forgotten about that.
So there will be a link to this in the show notes.
So normally we would say, who's talking to us? Right now, comments and water bottles are on hold. We have supply chain issues, obviously related to COVID. That and comments are currently off on the website as of last time I checked because of all the spam. We've got to go in there and fix that. We've just both been slammed for the last several months. We'll get to it eventually. So just go ahead and reach out to us, send a comment, and when things come back on, we'll be good to go.
Also, we are at the end of our supply of water bottles, so we may not continue doing water bottles. We are open to suggestions. So if you have a suggestion as to what we could do instead of water bottles, and I'll go ahead and say this, not coffee mugs. Way too many other dev podcasts do coffee mugs. So we like to be a bit unique. If you have any suggestions, something that you think, wouldn't be too expensive for us to buy in bulk, let us know. Send us an email to neckbeards@completedeveloperpodcast.com. And guys, you can still leave comments on our social media. We post all our episodes to Facebook, Twitter, and LinkedIn. We're also on Instagram, and I think we're on Tumblr. I really need to double check that. Or you could join the conversation anytime via Slack by going to slack.completedevelopernetwork.com.
Web APIs are often the best way to go when different parts of your application need to communicate, or when people outside of your organization need to communicate with your application. Not only are web APIs based upon a widely understood and implemented protocol, but they are also widely accepted across industry. Further, if your API is structured properly, using HTTP enables developers using a wide variety of platforms and languages to easily interact with it.
However, there's always a price to wide acceptance and easy use. Usually, that price is that there are expectations as to how your system will behave. These expectations are both obvious and they can sometimes be surprising. This is the case with building REST APIs. While many concepts are fairly obvious and easily understood, their implications can, at times, be surprising.
Before we get into the episode, let's do a quick little review of REST. REST stands for Representational State Transfer, and it is an architectural style for communications between systems on the web. REST systems are characterized by statelessness and separation of the concerns of the client and the server.
They're defined as a request response between the client and the server.
Yeah, and there's a few important parts to this whole thing. The first is the path. That's the URL that you are interacting with. That's the endpoint on the server.
Mm-hmm.
The next important part is the verbs, which indicates the intent of the request that you're making.
The next is the body, and this is the payload of that request. It is the meat, the content of it. There's also the header, and this is the metadata about the request.
Yeah. Then there's also the response code, which indicates the result of the request. Along with that, there is the actual response, which is a payload that comes back.
So the response code is this was a successful or a failed request and details about that, whereas the response is what comes back.
Right. And so part of the idea there is that you don't have to parse the response to find out whether it was a success or not.
Mm-hmm.
So you can determine, okay, the server says this is a failure, not my parser screwed up.
Yeah, exactly.
So that fits into the whole separation of concerns. As we go through this episode, we're going to discuss some of the anti-patterns that you'll commonly see. But in the meantime, if you're not familiar with this stuff, check out episode 219 of the podcast for a deeper dive into this material, because we covered that fairly thoroughly, I think.
Yeah. So as Will was saying, in this episode, we're going to go through some anti-patterns that you're very likely to see and that you need to avoid when working with and writing REST APIs.
Yeah, and the first one you're going to see all over the place, unfortunately, is improper use of response codes.
Oh my goodness.
Especially like if you have somebody that's like, oh, let's do a RESTful API and they don't know what that means, you're going to see a lot of this. There are known response codes for various states of the server. You should be using them. If you don't know what they are, go figure that out before you write an endpoint.
Mm-hmm.
So let's talk about a few of these. This is just
I'll tell you the most frustrating thing I've had to deal with, and I used to get really, really upset about it until I realized that the code was not designed to be used the way it was being used. But basically, it was an internal service, sort of a microservice that I had to contact. That if it errored, it wouldn't send back an error; it would send back a success with the error code
in it. Yeah,
with like the error, the whole error in it. Because what it was designed to do was work with a command line app and be sort of like the integration between that command line app and the server. But it got sort of overloaded.
Restified.
Yeah, basically.
Yeah, I have a similar story like that. The code in question was, again, not designed to be used. It was designed to not get the guy fired, where an HTTP response code of 1 was always returned because 1 is true.
Okay.
Yeah, that was new hotness. So that you're not ignorant like that person was, let's talk about the response codes and what they mean. The first set is your informational responses. These go from 100 to 199. And there's really not a whole lot of notable ones, but one of them is 101, which is switching protocol. It's like going, hey, we're going from HTTP to HTTPS, or we're doing some other negotiation strategy in there.
Next are the success responses. These are 200 to 299. And the main ones you'll see here are either 200, which is okay. And this is the issue I was having. I was getting a 200 response back, but it was erroring. So what I was expecting was 200 response back and then a specific type of response. And my app was erroring because it was trying to read that and going, hey, this is a string, not what you were expecting.
Right. That's why you separate that stuff, right? Like that's why
Yes.
it's in the response code, is so that you can branch on it before you try to parse it. Because again, like this, bear in mind when this stuff was built, parsing text was not cheap, right? Like
Mhm.
we're talking, early 90s type technology. And so it took a while for the payload to come down and for you to try to parse that. You load it all up in a memory just to have it crash, and then you deal with the response, means that everything gets really slow and there's errors. Whereas you can just go, oh, it failed, or
Yeah.
it succeeded, and then branch on that. So yeah, we use 204 a lot as well, just to indicate that the response of a post, for instance, like, yep, here's the stuff, there's no data, or those kind of things. The next class of stuff you'll see are redirects. Redirects go from 300 to 399. One of the most common ones is 301. That means that that resource got moved permanently. You'll use this a lot for search engine optimization type stuff, so that Google bots, when they hit a link, go into your site, it goes, oh, this isn't where this is now, it's over here.
Mhm. The next one are the 400 to 499, which are client errors. So these could be like a 401, which is unauthorized, a 403, which is forbidden, and then everyone's favorite error code, the 404, not found.
Right. Which is 1/5 of 2020, which I think is notable considering how this year is going.
I've seen those memes. Yeah.
Yeah. It's, I just saw that and I'm like, that's a little too close to home to be comfortable with.
Yeah.
Now, this does say client errors, and it is supposed to be client errors. I have seen this happen at the server side where everything was forbidden because somebody screwed up. This means you're requesting something that the server does not think you have permission to, or does not think is there. That does not, in fact, mean that you shouldn't have permission, or that it isn't there and they just screwed up routing.
Yeah.
It's a probability thing. Like the client is probably the one that screwed up.
When you say client, what are you talking about? Like client API, client as in
this could be
making
the
call?
web browser. This could be like your Angular app. This could be a console app calling out to a microservice. Could be another microservice. Could be AWS Lambda, checking stuff at it, and it's whatever.
See, what I use these errors for, I mean, first the unauthorized and the forbidden, and then are for, hey, you're usually unauthorized as you don't have the right authentication.
Yeah, you didn't log in, goober.
Yeah, you didn't log in, or the app calling into the API didn't use the right token or whatever security measure we're using for that particular application. And then what I like to do is I differentiate here between, this is something that the API caught the error versus it's an issue with the server. And it's how I tell, hey, this is me that needs to fix it versus this is ops that needs to fix it. Because if it's the next one we're going to talk about, which is the 500 to 599 server errors, that usually means for me that it's an operations thing because it's something wrong with the server or something not set up correctly.
Yeah, and the way I've seen client errors explained also, because people have a hard time understanding the difference between unauthorized, forbidden, and not found.
Mm-hmm.
Like in a business context, for some reason, and I know it takes a minute for the differences to click in your head. Unauthorized means you forgot your keys when you got home. Forbidden means that the key that you're trying to use does not unlock the door. Not found means you're at the wrong house.
That's a good way of explaining it.
Yeah. And I forget who did that explanation. It's another cranky developer, which is not like I hang out with that many of them, right? So that doesn't narrow anything down. Speaking of cranky developers, The next category is server errors, and these are from 500 to 599. And the most common one you're going to see all the time, especially in Beej's code, is 500 internal server error. I'm joking. Hey, I got one of those today. It was a Stack Overflow, so I can't.
Well, that's what I was saying. If you get a 400 error, then it's something like something went wrong within the code, or maybe you're not passing the right parameters in. You're not doing, there's something wrong in that interaction. If you get a 500 error, that means it likely didn't even get to my API yet.
Yeah, it's in the middleware somewhere,
Yeah.
puking on itself.
And that's when I call the operations team and go, "Hey, I'm getting this error. What's up?" And they're like, "We'll restart the app pool, and that fixes everything." It's operations version of turn it off and back on again.
That's almost exactly what it is.
That's why that was the joke.
Yeah.
Okay. Thank you
I know.
for ruining my joke. But
well, it's a joke and it's funny. It's just kind of like really uncomfortable the more you think about it. And we're still doing that. Yeah, it's really common to see incorrect response codes. Like you said earlier, returning a 200 along with an error in the payload.
Mm-hmm.
Now, I've seen people do this with like wrappers in the payload for some kind of, you return a, 500 or you return a client error. You might like return a, 403, but you might send a payload back with it or something where what's in the payload is what the app should be displaying versus what the developer should be dealing with.
Mm-hmm.
So like you have internationalized error messages or whatever. I've kind of seen that approach, which I think is probably okay-ish. It's just not real intuitive.
The place I did this most was with file uploads when we were uploading to like a long-term storage service, and I needed the UI developer to be able to tell their person, "Hey, a difference between, all right, you didn't attach a file when you tried to upload this versus, hey, there's something wrong with the service we're using. Come back later and try again."
Right.
And it's the same endpoint. So like I needed to be like, all right, I need them to know. And so I would attach a message within the error that's like, here's what's going on, and then they could use that to know what to display.
Yeah, I mean it's one of those things where protocol's nice and all, but not getting a call at 2:00 in the morning is nicer. People are very willing to bend it. And speaking of things getting bent, another common mistake is to create redirect loops accidentally. Those are always fun. I mean, eventually they'll stop, but like your clients will be like, "What in the world is going on? The server just flipped out." Because you can do that, if you set your redirects wrong.
So the next type of errors that we're going to talk about are improper use of HTTP verbs.
And verbs basically express intent in a roughly CRUD fashion.
CRUD is create, read, update, delete.
Yeah. The thing is there's some other bits in here too. A get.
Yeah.
I mean, a get gets things from the server. So this is like go and get the, this box of crayons out of the cabinet. Mm-hmm. That's a get. A head request is identical to a get, but doesn't get the body. So that would be like, look in there and see if there's a box of crayons. Yeah. Post submits an entity to the resource. Hey, I bought you a box of crayons. Put it in the cabinet. But note, we don't call that put. Post it to the cabinet. A put replaces a resource. Hey, this box of crayons, they're made out of lead-based paint. Let's replace those because, I know that you eat crayons because you think they're tasty.
Yummy.
Yeah, figured you'd say something like that. A deletes a resource. Hey, these are lead-based paint crayons. Let's get rid of them. We haven't gone to Target to get more yet. A patch applies a partial modification to a resource. Hey, nobody likes the white crayon. Replace it with this green one that's way cool. Because nobody uses the white crayon. Like that's like the immortal crayon in every box. Right? Like you think back as a kid, that crayon is always there.
True.
You can only use it to write on, nice walls.
Yeah.
And get a whooping.
So typical mistakes in this area include using the wrong verb for the intent of your action. And this can get tricky when you have like blended calls. So like if you are searching and you have to pass in a payload to run like of the information you want to search by, but then you have to pull, then you're also getting things back from the server.
Yeah, and we'll get into some of that is pathing, but I mean, I've run into the
Yeah.
same thing too, right? Like you can put a lot of stuff in the URL, but after a while, it's like, look, I'm searching on 20 different parameters. I'm not putting all those in the query string.
Yeah.
Like that's just not happening more than likely because everybody's going to have a hard time with that. It's going to be hard to deal with. So yeah, this is a pretty common mistake. One thing I've seen people do is go, hey, look, a complex search. They're like, look, I'm posting a search. Fine, I'll just record the search. Now it's a post. Leave me alone. I've seen that one too. Just to get rid of the purists. You're going to bend these rules on occasion because of implementation details. But some stuff that you really need to be careful about is stuff like using a Git to make changes. This is especially bad on the open web if it's a path that gets crawled, because Google will now be making changes to your system by hitting an endpoint if they can get to it. The other thing too is a Git typically does not get cached, or rather typically does get cached. And so the request may not actually really reach the server. So there's intent expressed around these actions at the browser level that you need to be careful about.
The next one is the incorrect use or complete ignoring of MIME types.
Well, they are silent, right? So
I had some conversations about this today. A lot of conversations today. We won't get into that.
Yeah. So there's a lot of these. There's only a few in most apps. And, here, we're going to kind of talk about a few of them. Text/plain is exactly what it sounds like, raw text, and just completely ignore our episode on string manipulation that tells you exactly how raw text is not as simple as you thought it was for the purposes of this discussion.
Yeah. The next is text/HTML. It's also exactly what it sounds like. HTML for use in the browser.
Yeah. And people can do a web page in like 30 minutes. So there's no reason that this is complex. I think everybody here agrees. I can't even say that with a straight face. Yeah. That just broke my sarcasm meter. Application/JSON is pretty common as well. JSON stands for JavaScript Object Notation, which is a serialization format that is human readable, except when it isn't.
Hey, it's still easier than XML.
Yeah.
Unless you've been using XML for a long time.
Yeah. In other words, you've been working on config files for Microsoft products.
Hey, they're moving over to JSON in .NET Core.
Yeah. Well, they have to, because otherwise, why not just do it in binary and just go, hey, just open a hex editor if you want to edit this. I think that's reasonable. The next one that you'll see a lot is application/x-www-form-URL encoded. That sends the body of an HTTP message as one long string with name value pairs separated by the ampersand. This is like crap that you post up from a form.
And the last one we're going to mention here, like Will said, there are a lot of these, is multipart/form-data. And this sends name value pairs as separate parts of the message separated by a string boundary. We use this for passing in files when we're uploading things. Mainly, that's what I think of, because that's what I've been working on a lot lately. But that's the main use for this, because it overcomes the length restrictions in like JSON strings.
Yeah. And there's always stuff like that to work around on these kind of implementations. So stuff like that is there for that reason. So as far as MIME types go, the client is responsible for specifying what type of content they want, and they negotiate that with the server. A common failure is when this doesn't happen. So for instance, the client is asking for XML because reasons. You have an object, you can serialize it to JSON, you don't serialize it to XML, and they asked for it, and you didn't say, oh, we can't give you that, but you just hand them JSON. That is an incorrect behavior at the server level.
Yeah, you should throw an error if you can't serialize it to XML. So, well, I mean, I guess I could see some reasons why you couldn't turn JSON into XML, but...
Well, and there's frameworks that have issues, and you also have to bear in mind there are people who do not seem to understand that commercial parsers and serializers and open source packages like that are a good idea to use. And so they do it with string manipulation instead. And so they literally have to write something that does that. And so they haven't written it.
Yeah.
So, and especially on older systems, this is something you'll run into.
Now, another common mistake is to completely ignore the content type requested or to send content back that doesn't have the MIME type set, like sending JSON as text, for instance.
Yeah. And, you can kind of get away with that
Mhm.
until somebody is strictly trying to implement it and they're looking at what's going back and forth and they're like, why is this text?
Yeah.
And they may be making assumptions based off of the API signature, especially if you're using something like Swagger, for instance. It's like, oh, okay, this thing returns text. Well, it's actually JSON. I need to have something that can parse JSON to read that versus whatever I'm going to try to do with raw text on the open web, which is probably psycho anyway.
I forget what it was I was working on, but I had something not long ago where it was .NET Core API, but it kept returning. It was a JSON object. It kept returning it as text, like as a string, and it's going to stringify the JSON when it sends it back, but it was coming in. So like when I was testing the API, it was coming into Postman as a string, and it was so frustrating to me. But then I talked to my UI developer, my Angular developer, and he's like, "Yeah, it doesn't matter." He's like, "If it's in JSON, no matter if it's a string or not, whatever it comes in as, I can parse that if it's JSON string." And I'm like, "I know, but it should be coming in as JSON. It's not working right."
Yeah, it really, because well, the other thing too is if you're not returning the right thing and you have something on the other end that generates code for talking to the thing, it's going to be wrong.
Yeah. That was my thing too. I'm like, yeah, you can do it now, but looking down the line, if we switch out our front ends, where it's going to expect JSON and it's going to come in as a string, and it's just like, I've got to get this figured out and working right. And I eventually got it working, but it was just, I don't even remember what I had to do. It was a while back, but it was frustrating at the time.
So speaking of frustration, another common category of issues is incorrect use of or ignoring of caching. And this one's one that actually happens on both ends. The purpose of caching is to reduce the use of bandwidth, reduce latency, reduce load on servers, and possibly hide issues with connections. So if you have a transient error, if most of your clients are caching their results anyway, it doesn't hurt as quick. You can get out of it essentially before everybody notices that you screwed up.
Mm-hmm. Caching is heavily dependent on your HTTP verbs, which is why Will was talking about that when we were talking about the verbs. And it's important because if you have your verbs messed up, you're going to have your caching messed up by default.
Right. And I've seen things even where browsers did this wrong.
Yeah.
On the iPad, I think it was Safari cached the results of post requests.
Yeah, I've seen that.
For a little while there as a bug. I mean, you talk about a nightmare because the web development team is like, oh, it doesn't do that. And there's like one guy that's going, yes, that's what's happening. And there's like a 4-hour argument.
Yeah.
Because these assumptions are so deeply rooted and they're necessary for things to work. And so when they don't work, you're going to have a bad time.
That said, GET requests are cached by default.
Post requests are not cached by default because they change state, but they can be cached using the expire and cache control headers.
Responses to put and delete requests are not cacheable at all. You don't want to cache those because...
Yeah, like what would you cache a delete?
Yeah.
Like, so if you delete it again, you're going to say we deleted it before? Yeah, like it doesn't make sense. It's like you cache it.
Yeah, if you delete something and then you try to delete it again, you need to get an error because something's wrong.
Yeah,
if you're trying to delete something you already deleted.
So now there's some other headers that are important here, in addition to the verbs. There's the expire header, and that's used to indicate when the result of a request is to be considered stale and needs to be revalidated. This is a date.
Yeah.
Essentially.
That's what you would use if you wanted to pseudo cache a post request. It's the Mission Impossible header. This message will self-destruct in 8 seconds. But another one, e-tags are string tokens that a server associates with a resource to uniquely identify the state of the resource over time. When the resource is changed, the E tag changes.
Right. And so one thing you can do here is if you do like a head, you can actually do that call and say, oh, the E tag is not changed from what I have. That's one of the intents here.
Oh, no, that makes sense because I was like, yeah,
If you got a big honking payload,
yeah,
that's worthwhile. Here's the thing with cache control headers. They're composed of a set of directives that indicate whether a response is cacheable, who it can be cached by, and for how long.
common mistakes in this area include not caching, caching for the wrong amount of time, or caching when you shouldn't.
For instance, caching things like keeping passwords and stuff in cache, not a good idea because of security. That's one thing. Keeping things like if you have an app that dispatches jobs to a service and says, hey, do this thing for me.
Mhm.
And then you check and you go, what's it doing? Well, if that thing's cached for 24 hours, you don't have enough granularity on your responses to know whether something's done or not for 24 hours. That's dumb.
Mhm.
I've also seen things where people will just go, yeah, just cache it for a minute, and they just do it across the board because like, well, that'll help with a lot of our requests, and it probably will. But usually what you have to do is actually start thinking about how frequently something changes, like what its volatility level is, and then you determine your cache duration based on that, not based on just random pulled out of the opening numbers.
Yeah. The next thing is improper request structure. It's also common to see people incorrectly structure things based on the type of request or response.
Right. So like in a GET request, most of the stuff you need should be in the path, not the body. In fact, I would pretty much say always, because otherwise it's a post. It's just, things get weird,
Mhm.
Otherwise. Similarly, stuff that's cross-cutting concerns. So like authentication tokens, caching directives, those kind of things should be placed in headers instead of in the body.
Data being placed into the system via put, post, or patch command needs to be in the request body, not in the
Yeah.
path or the head.
Right. There is a little wiggle room here on some of this
Mhm.
because I've seen things where somebody will post and say, hey, I'm like we do this with our Elasticsearch implementation, right? It's like you post to this route with this tenant ID and it says update their Elasticsearch stuff for this tenant.
Mhm.
There's nothing in the body, it's all in the path.
Yeah.
But typically you don't do that. It's just we do that because it makes the URLs clean and
Mhm.
that's already segmented by tenant. There's very few circumstances where you do that. Your response structure is under similar constraints based on what HTTP verbs were supplied. There's stuff that should come back in the headers. There's stuff that should come back in the body. The thing about mixing this stuff up is it tends to be confusing to consumers of your REST API, and it's best avoided if you want your system to be easy to work with, which is the reason you're building an API, right? So some disparate system out there can talk to your system.
Now, sometimes I have seen where a post will return the object posted.
Yeah.
Because
Especially if it's an update or it's a new one with an ID now.
because what'll happen, like if it's a singular, like, all right, we're updating this one thing, this one table, you can just return the ID. But if you're doing a deep object that has connections on multiple tables, it's going to be complicated to do that. So it's just easier, I found, to return the object with those IDs in.
Yeah, and the other reason I'll do this is sometimes other things besides just the ID get updated on the server.
Yeah.
As well. So it's not just the ID, but it's like, okay, here's this string and we're going to go get you some other piece from some other system and put it back into that object and hand it back to you. And that needs to display on the UI.
Yeah.
And so you just kind of have to do that so that the client can work with it. Now, the other thing you could do is you could also pass a token with your request when you do a post that says, hey, I'm going to ask for this token here in a minute. Go get it. But that's two requests. It's kind of a waste.
Yeah, that's what I was thinking. The other way to do it would be to do something like that, or to return the ID of the object and then have them do a get to pull back the object. And it's like, you're taking up bandwidth when you do that.
Yeah, or you give it like a topic ID and you have like a WebSocket push when the thing's done.
Yeah.
I mean, there's ways to do this, but really that's simple. And I think I'm not entirely sure that's completely with standard
Mhm.
or not, but like everybody and their mother does that. It's sort of like speeding. It's like, yeah, it's the law, but
Yeah.
what percentage of the population's following that one?
Mhm.
Speaking of errors, or speaking of sins and errors, poor handling of errors is another common category here. Error codes should accurately indicate what went wrong, along with who originated the problem.
Yeah. And like we said earlier, server side errors start in the 500s and generally indicate something's wrong with the server.
Yeah, or some piece of infrastructure back there.
Mhm.
Either the server, the database server, the network infrastructure, a gateway, that kind of, in other words, it's not the client's fault, probably.
Yeah.
A client side error starts with 400 and indicates that the client did something wrong. They went to the wrong path. They aren't authorized, etc. It's really common to get these mixed up. For instance, let's say that the client requests a resource that doesn't exist. If this causes a null reference exception, it's going to return a 500 rather than the 404 that it should, because it made a server side error, but it's really a client problem.
Mhm.
That makes sense. That's why I said there's a probability thing here, because developers do screw up on both ends.
Yeah. Also, you need to use the correct codes within each section to indicate what is going on. This helps with debugging. So if you have a 404, that means the resource isn't found, as opposed to a 405, that means you can't use a particular HTTP verb on that resource.
Right. For instance, you can't post to something that's just a static list that comes off the server.
Yeah.
Right. Because it's just a get.
So the next anti pattern or common mistake we're going to talk about is poor or no documentation at all. First off, weak or incorrect documentation can cause a lot of issues for anyone working with your API. This is funny. We've been
Facebook. Sorry.
We've been working on our
cough sometimes.
README files and updating our documentation, and I had I think I talked about this a week or two ago. I had to like let another developer work on what has kind of been my baby, been the API that I worked on for several years and stuff. And yeah, I had to hand it off to him to do a fix. And he called me. He's like, "Hey, so I went to update the README like we're supposed to, and I didn't find anything." I'm like, "Yeah, that was built before we were doing that." So all the stuff is in the all the documentation is in the XML comments on there. So we need to look into that. I was like, I know who to talk to about that, and I reached out to him like, hey, he's like, yeah, that's on the list. He's like, I just haven't gotten to that one yet. They're going through and updating all the older apps, but it's just like I haven't gotten to that one yet.
Yep. And written documentation like that is very useful. But you also should be building a lot of your documentation around the notion that keeping documentation close to the thing being documented is
Mhm.
valuable. So like your XML comments are a good example. That should be there even if the other's not. It's also really handy to look into something like the Open API specification or Swagger for making it easy to work with and test out your API without having to write custom code. So these things will actually build a UI up. They'll build a UI up where you can test things like your posts and your gets and all that kind of stuff, and it's available.
Yeah. Any sort of API test bed should allow clients to work with their own data, or it should let them work with a reasonable sample data set.
And by the way, that sample data set needs to be sharded per tenant. I've seen APIs that do this. They're like, oh, yeah, here's our sample data set, and clients can work with it. And you'll have clients test out pushing their stuff into there, and it's a shared data set among all the clients. Like, don't do that.
No. So I heard someone else use the word or the term "you just should" all over yourself.
Yeah.
And it was a thing on the Enneagram talking about the ones, but I was like, that's a will phrase.
Yeah.
I just want to let you know other people are using that phrase.
Yeah. I didn't.
Oh, I'm sure you didn't,
Probably.
but I just, I thought it was cool that like other people who are publishing content were using that phrase too. So I just want to throw that out there when I read the word should. So
Yeah. But if you do have an API test bed, letting your clients work with their own data is really handy for them when they're writing integration points, because they need it to correlate to something in their system more than likely. And so you're going to want to have that set up. Like QuickBooks Online lets you kind of do that in your own little area.
mhm.
if you have something like Swagger, you can use it to generate client SDKs for your API in the client's target language. So, like the Open API spec lets you do this, and it'll generate, C# objects for talking to that project. It'll generate Java objects. It'll generate JavaScript
Mhm.
packages like npm module type stuff. That's really handy, especially if your team is not polyglot, because now you can support a wider variety of organizations versus having a developer be told, oh, well, you know what, this week you're not doing C# and you're not doing all the stuff that you like doing. You're doing Python and you're just dealing with a white space, baby. It's just better for your dev team if you can do that.
You should also consider having a test environment for your clients so they can try things out without the risk of damaging their own data. We have a UAT, user acceptance testing environment, just for this. Actually, some of the conversations I have had the last several weeks have been about why we don't need to push stuff directly from my computer to UAT.
Yeah, because you also have to have a testing cycle
Yeah.
there.
Why we have a dev and a test, and it's like, yeah, once I push it up, into the repo, it shouldn't go directly to UAT. We have a process here. But you have those people in upper management who are so separated from the development lifecycle that they don't get that.
Yeah, and they don't understand what the difference is between, oh, you're done with this code. It's like, I'm done with it, but there's 10 other people it has to go through before it's actually out.
Yeah. Yeah.
You don't want me to be the arbiter of what ends up in production or UAT.
Very true.
Or go ahead and let me be, and I will disabuse you of that notion through experience. However you want to play it.
Yeah.
Such environments should also have ways of generating common errors based on input data so that clients can test their responses to common issues. I've seen this with payment processors a lot. So if you do like a $2 transaction, it'll automatically deny it
Mhm.
in the test environment so that you can test what is your workflow when a transaction is denied.
Yeah, I've seen
Or
that.
what is it if you're doing like credit card stuff and it's expired card, like you probably have a whole dunning workflow to figure out, how do we get this person to update their card?
Mhm.
And you need to be able to trigger that for automated testing or manual. And so you got to have stuff like that in there.
Now, most API documentation like this is produced using some form of annotation on your code, and you'll want to prioritize keeping this up to date during the development lifecycle. That's what I was talking about. That's what we were doing with, like, just the process is before your code can get accepted, you have to update documentation.
Yeah.
And that's for our newer stuff. The older stuff we're still working on catching up to the way we're doing documentation now. It is a really good idea because I have had to go and work on stuff where a developer built it a couple years ago, didn't do the best job documenting it. Other people came in and made changes, did not document it. And you're just like, I don't even know what this does. And even with like an IDE like Visual Studio, you're like, all right, this points over here, but there's nothing over here. It just sort of sits and spins and then returns nothing.
You know what they call a dead animal that turns to stone?
Yeah.
Call it a fossil, right? You know what a fossilized comment is? It's a lie.
Yeah, that's good. That's good.
And the same thing with documentation, except it's a lie with multimedia.
So the next anti-pattern is poor consideration of scaling. As an API gets used more frequently, scaling will become an issue that impacts more and more of your clients. And they may decide, hey, we're going to use this API as, that was built to integrate a command line application with the server as a REST endpoint for all of our websites doing similar things. Oh, and now we want to add this other functionality and this other functionality.
And we're going to call it from all the client machines instead of from our server, because why not just do it in JavaScript and have them all individually hitting it instead of no caching? Yeah, caching will help you, but it's not enough once you get much scale at all. So early on in your design, you should consider replacing, anything that's synchronous with asynchronous workflows, if it makes sense to do so. So typically this is done with webhooks. They do a request. They go, hey, do this thing for me. They don't get a response right now.
Yeah.
Instead, they pass a URL that says, call this back when you're done.
Yeah, that makes sense.
So that, they're not sitting there waiting on you and you're not generating load with the waiting and the polling type setup. In fact, any kind of polling loop that you have probably should be considered something to replace with webhooks in general. Don't call us, we'll call you is a attitude that will protect your servers from wasting time on requests that provide no business value.
Yeah.
You might also want to consider pre-building response payloads that are frequently requested and infrequently changed. Such things could potentially be stored cheaply in a CDN or something like blob storage. So like if you have a document of, and I mean a data document, right? So like all of a user's preferences, well, they don't change those that much, right? So you could potentially stuff that in a JSON document and put it somewhere, and pull it down when you need it versus constantly joining a whole bunch of tables to get it. It's just there.
Also, make sure and rate limit client requests while separating test and production systems. These strategies are going to help keep client mistakes from damaging your system.
Right. So like I've worked with guys, they're like, okay, we'll poll this endpoint every 5 minutes. And they're like, oh, they're doing win forms, for instance, and they're not familiar with it. And they use the timer control, right? Okay, the timer interval is set to 5. We poll every 5 minutes. Now, it turns out it actually, if you set it to 5, it won't really work because the timer granularity is about 53 milliseconds. But 5 is actually 5 milliseconds, not 5 minutes. And I've seen this done.
Really?
Oh, yeah, because somebody didn't know. And they weren't looking. They're just like, oh, here's the interval, 5 minutes. I'm sure it's a minute timer.
They didn't check. They just...
Right. They just rolled with it.
I have been blessed to not work with anyone like that yet in my career. Hopefully I won't ever.
I'll tell you, I don't know that it's a blessing because once you realize just how deep the well is, you don't drink out of it.
Yeah, I suppose.
You realize what's in the bottom of that well, you just don't trust the bucket anymore.
I suppose. No, but unlike many other API anti-patterns here, this one will be constantly morphing. Just an ongoing concern. It's going to be something that you're always going to be dealing with.
Yeah. And so you need to design up front because remember, if you change your design, your clients have to change how they interact with you. So you do this as early as possible. Otherwise, it's going to be a redesign. Fix it.
All right. Now, the final one we're going to talk about is versioning issues. Your app will evolve over time, and it's unlikely that all of your clients will evolve at the same speed, even if they're all internal. That's why versioning is critical to success.
Yeah. And if your application is not new, you'll probably need to support at least 3 versions of it in production. That's the actual reality. You'll need to have the beta version of your next API version so that clients can start migrating. You can't just flip the switch and then, oh yeah, here's all our new APIs, drop everything you're doing and rewrite everything.
Yeah.
Facebook. They've done that to me a few times in the past. You can tell I'm still bitter. That's a very ugly client experience. And this was years ago. Now, you'll also need the existing or stable version of your system for what the client is actually trying to do with your system in real time. Like they built something to integrate with it. They get a value out of it. That system has to stay up.
Now, I do like that certain places that know, hey, people are going to especially when it comes to frameworks and stuff like that, where it's like, all right, people are going to build something with this and it's going to last for years, where they'll have a long-term stable version versus just the stable. So the most recent stable, and then they'll have with .NET Core, it's the 0.1. It's like right now, 3.1 is the current long-term stable version. The 0.1 version is their long-term stable. So that's the one they're going to maintain. Even when they've gone on to version 4, they'll still be maintaining 3.1. They may not maintain the other versions.
Right. So they won't maintain 3.0, for instance. Yeah. And that's a good strategy, especially for really, really big companies. But even for relatively small companies, you're going to want all 3. You're going to have to keep the previous version online for a pretty good while so that clients can migrate. And developers love to go, oh, we're going to force everybody off in 6 months. That's great. But the problem with that is the developers don't actually have the power to make that decision. Most organizations, we simply do not have that power. So you might as well plan for this up front and go, we're going to support the old version for a good long while. Build it accordingly.
Yeah, one thing I've done and this was just for some internal services, is to build backward compatibility into it so that we could support that and then go through and slowly make the updates as we were able. You'll also have multiple environments. At the minimum, you'll probably have environments for production, testing, and sales demos. You'll have to keep these separate from each other, and they probably have to work across all your versions.
Yeah. One thing I see a lot of companies doing is having the test environment and the sales environment be the same.
Mm-hmm.
That lets one of two things happen. Either your development team breaks the sales team, and the sales team is where the money comes in. So that won't happen very long, or the sales team chokes the development team because now the development team can't push stuff out to test until sales doesn't have any need to show stuff to clients, which is either never or you're about to be unemployed.
Yeah.
Be really careful with a lot of this stuff because a lot of this stuff really steps up a level from just plain old developer thought processes.
So guys, a lot of apps have one or more components that are exposed through a RESTful API. If you do this well and make it easy to work with your API, people will find it easier to start connecting to your system. This is one of the best ways to get and keep larger clients, as most companies are far more hesitant to disconnect from automated systems than they might be from manual ones. Building your API using REST best practices will reduce the friction for these clients. That pretty much wraps us up. Before we close everything out, Will, what do you have for us this week for Tricks of the Trade?
Well, I do want to kind of, hammer on a point that I made earlier that anything you do is political in a work environment. You make a code decision, there are political consequences downstream of that. You write a document, there are political consequences. A lot of people don't like that that's the reality, but the fact of the matter is that it is omnipresent, just like gravity. You're going to have to deal with it, and the way you design things is going to have to take that stuff into account. This is why things like Conway's Law apply the way they do, is because this is a constant you can't escape. So always be considering that stuff, even though you may think it doesn't matter. It can be one of the biggest things that damages your career if you get it wrong. So that's all I got. If you have a question or comment, please email us at neckbeards@CompleteDeveloperPodcast.com. Our theme music is an excerpt from Stand By for Titanfall by Pure Bells, available on SoundCloud and licensed through Creative Commons.
The intro music for IoTs is Hillbilly Hip Hop by Jason Belcher. For references, show notes, and to sign up for weekly emails with extra tips and insights, be sure to check out the website at CompleteDeveloperPodcast.com. You can also follow us on Twitter at CompleteDevPod and like our page on Facebook to keep up with news about the show. Catch us each week as we broadcast live, talking about what's going on in the tech world and answering listener questions.
Learn more about all of our shows and groups by going to CompleteDeveloperNetwork.com, where you'll find links to Junior Developer Toolbox, Developer Launchpad, and our other communities. Thanks for listening. See you next time.